Hello, and welcome to our lesson on presenting and interpreting numbers in standard form. In this lesson, we'll dive into the concept of standard form and understand how to efficiently handle and read numbers expressed in this format. We'll begin by defining what standard form is and look at some examples to clarify this concept. Then we will learn how to convert ordinary numbers into standard form and vice versa. Finally, we will apply this knowledge to solve problems, demonstrating how useful this technique can be in various mathematical contexts. In our previous lessons, we have built a solid foundation in approximations by learning about rounding numbers. This skill is crucial because it helps simplify complex numbers and makes calculations more manageable. With this foundation in place, we can now introduce standard form, a notation used to express very large or very small numbers in a compact and understandable way. Let's get started. Standard form is crucial in mathematics and science because it simplifies the process of writing, comparing, and performing calculations with very large or very small numbers. For example, it is far easier to work with 3 times 10 to the power 8 than writing out 300 million every time. Standard form, also known as scientific notation, is a method of writing numbers that makes it easier to handle large or small values. The general format is a times 10 to the power n, where a is bigger than or equal to 1 and smaller than 10, and n is an integer, positive or negative. So for example, 0.00056 in standard form is 5.6 times 10 to the power of minus 4. Now let's go through how we're converting numbers to standard form. Here's the step-by-step process. Step 1. Identify the position of the decimal point in the original number. Step 2. Move the decimal point to create a new number, such that AI is bigger than or equal to 1 and smaller than 10. Step 3. Count the number of places the decimal point has moved. This determines the exponent n. Step 4. Write the number in the format a times 10 to the power n. Let's turn to a couple of examples. Convert 45,000 to standard form. First, let's move the decimal point. We need to move it 4 places to the left to get to 4.5. That means 4 is n and 4.5 is a. We write this as 4.5 times 10 to the power 4. Our next example is convert 0.0072 to standard form. Move the decimal point 3 places to the right to get 7.2. Again, 7.2 is a and n is minus 3. So we can write this as 7.2 times 10 to the power of minus 3. Finally, let's look at using standard form in calculations. In multiplication and division, the rule is that we multiply or divide the numbers that aren't powers of 10 and add or subtract the exponents in the powers, based on the rules of indices that we have learnt. We can see this in the on-screen examples. For 2 and 10 to the power of 3 times 10 to the power of 4, we multiply 2 and 3 and add the exponents of the powers of 10. 2 times 3 is 6 and 3 plus 4 is 7, giving us 6 times 10 to the power 7. Likewise, for this next example, we find 6 divided by 2 is 3, and 5 minus 2 is 3, so the expression can be simplified to 3 times 10 to the power of 3. For addition and subtraction, the rule is that numbers must be expressed with the same exponent of 10 before adding or subtracting the a values. This is evident in the on-screen example in which both powers are altered to being 4 before the numbers are added. Great! Now let's dive into some examples to see how we can apply the concept of standard form in GCSE level problems. Our first problem is convert 0.00032 to standard form. Identify the first non-zero digit. Here it is 3. Count the number of places you need to move the decimal point to place it just after the 3. This is 4 places. Write the number in the former times 10 to the power b, where ai is the significant digit followed by any other significant digits, and b is negative because the decimal point moved to the right. So 0.00032 in standard form is 3.2 times 10 to the power of minus 4. Our next problem is convert 2.7 times 10 to the power of 3 to an ordinary number. First, we need to recognize that 10 to the power of 3 means that we have moved the decimal point 3 places to the left. So in order to return the expression to an ordinary number, we need to move the decimal point back 3 places to the right. So, starting with 2.7, move the decimal point 3 places to the right, filling in zeros as needed. 2.7 times 10 to the power of 3 becomes 2700. Let's try a few more examples. First, let's multiply 3 times 10 to the power of 4 by 2 times 10 to the power of 3. Step 1 is to multiply the significant figures. 3 times 2 equals 6. Then add the powers of 10. Doing this, we get 10 to the power of 7. So, our answer is 6 times 10 to the power of 7. Let's move on to our next problem. Next, let's divide 5 times 10 to the power of 6 by 2.5 times 10 to the power of 2. First, we divide the significant figures. 5 divided by 2.5 equals 2. Then, subtract the powers of 10. 10 to the power of 6 minus 2 is 10 to the power of 4. So, our answer is 2 times 10 to the power of 4. Lastly, add 5 times 10 to the 6 and 2 times 10 to the 5. First, we need to convert one of the numbers so both have the same power of 10. 2 times 10 to the 5 converts to 0.2 times 10 to the 6. Next, we add the significant figures. 5 plus 0.2 equals 5.2, keep the common power of 10. So 5 times 10 to the power of 6 plus 0.2 times 10 to the power of 6 equals 5.2 times 10 to the power of 6. In today's lesson, we began by defining standard form and understanding its significance in mathematics and science. We then delved into the step-by-step process of converting ordinary numbers to standard form and vice versa, with clear examples to illustrate each step. We practiced converting both large and small numbers into standard form and reverted them back to decimal form, ensuring a solid grasp of these conversions. We also covered how to perform arithmetic operations like multiplication, division, addition, and subtraction using numbers in standard form, emphasizing the rules for managing exponents. By mastering standard form, you have added a powerful tool to your mathematical toolkit, enabling you to handle and interpret large and small numbers with ease and precision. Watch the rest of the GCSE Maths course at Sophos Education.